In today's lesson, we're going to look at an introduction to the periodic table. The periodic table is a tabular arrangement of elements in rows and columns, showing the regular repetition of properties of elements. The periodic table is built on the modern periodic law, which states that the properties of elements is a periodic function of the atomic number. What this means is that if you arrange elements in order of increasing atomic numbers, that similar chemical properties will reoccur at regular intervals. Elements can be arranged in horizontal rows called periods, or vertical columns called groups, as well as in blocks. There are 7 periods in the periodic table, and the information that each period avails us is as follows. The first one is that atomic number increases. This means that as you move from left to right across the period, that there is a progressive increase in the number of electrons by 1 as you move from left to right. Let's look at the first period, which comprises hydrogen and helium. Hydrogen has 1 electron, helium has 2. Looking at the second period, which starts from lithium and ends at neon. Lithium has 3 electrons, beryllium has 4, boron has 5, carbon has 6, and so on and so forth. So you see that as you move from left to right across the period, atomic number increases. The second thing to note about the period is that elements that belong to the same period have the same number of electron shells. For example, elements of period 1 have 1 electron shell each. Elements of period 2 have 2 electron shells each. Elements of period 3 have 3 electron shells each, and so on and so forth. And finally, for periods, properties change progressively as we move from left to right across the period. For example, the left side of a period usually comprises of metals. Towards the middle, we find non-metals or metals. And to the extreme right of the period, we find non-metals. Elements can also be arranged in vertical columns called groups. There are 18 groups of elements in the periodic table. There are actually 2 methods of designating groups. The traditional method involves the use of the letters A and B, meaning that going by the traditional method, there is group 1A as well as group 1B, group 2A as well as group 2B, group 3A as well as group 3B. But according to IUPAC, which is the acronym for the International Union of Pure and Applied Chemists, to avoid confusion, the use of the letters A and B is no longer accepted. Instead, elements are designated into one of 18 groups as you move from left to right across the periodic table. And elements are arranged in groups based on the number of electrons in the outermost electron shell. So what this means is that elements that belong to a particular group have the same number of valence electrons. That is, they have the same number of electrons in their outermost electron shell. The information that each group avails us is as follows. The first one is that elements of a particular group have similar chemical behavior or similar chemical properties. And the reason for this is because elements of a particular group have the same number of electrons in the outermost electron shell. The second information that a group avails us is that as you move from the top of a group to the bottom, that there is a progressive increase in the number of electron shells by 1. Let us look at group 1, for example. 3 elements of group 1 are shown here. Hydrogen has 1 electron shell, lithium has 2, sodium has 3, Potassium that is not shown here has 4, and so on and so forth until you get to the last member of the group. Elements can also be arranged in blocks in the periodic table. And the criteria for arranging elements in blocks is the type of orbital that is being filled. Or we can also say that elements are arranged in blocks in the periodic table based on the type of orbital that the last electron of an atom of the element enters. The last electron of an atom of an element is usually called the differentiating electron. So this means that elements can be arranged in blocks in the periodic table based on the type of orbital in which the differentiating electron enters. If the differentiating electron enters an s orbital, then that element is an s block element. And examples of s block elements are elements of groups 1 and group 2. If the differentiating electron enters a p orbital, then that element is a p block element. Examples of p block elements are elements of group 13 to group 18. If the differentiating electron enters a d orbital, then that element is a d block element. Elements of groups 3 to group 12 are d block elements. If the differentiating electron enters the f orbital, then that element is an f block element. Elements that belong to the lanthanide and actinide series are f block elements. Thank you very much for watching, and see you in the next lesson.